So my last video, when the packet get here, I have not explained it clearly. So this time, let me try it again. Yeah, apologize. So I draw another diagram. Basically, it's the same diagram. A pod send the traffic through the packet coming here, come to here, and then how it knows to get it here. By the way, so this Flino.1 is a VXLAN VTAP interface, and the same here. So what this VTAP interface does is, when packet get here, it will do the VXLAN packet encapsulation for outgoing packet and the decapsulation for incoming packet. So in this example, we are sending packet from here to come here. So this is the sending side. This is a receiving side. So in order for this guy know why it need to send a packet to here, why it make that decision. So these two entry is very important. The bridge FTP show dev Flino.1 and the IP route to get it to this guy. So why I'm using this bridge FTP show? And the last time I explained, oh, you can think of this as a bridge. I think that can be confusing, and so I'll try to explain this time from the kernel point of view. And so I look at the kernel VXLAN driver code, and that is a VXLAN.c driver, VXLAN driver that is responsible for set up this interface in the kernel and set up the data structure for this interface, and for in packet VXLAN packet encapsulation and decapsulation. So for this, since we are talking about this is sending side, so this is the driver function, VXLAN driver function for packet for sending VXLAN packet, and so this is the actual packet transmission function. And the first thing it does is find the MAC address based on the packet destination MAC address this guy got. So when the packet comes from here to here, the destination MAC address has this guy. So when this guy when this VXLAN find MAC input with parameter with this MAC address, it will look for what if there's an entry match this. If there's an entry match this MAC address, and if there is, it will get the remote VTAP host. So in this case, it's my workload IP. And so once this guy find this entry, it will start actually transmit that packet. And but before transmitting the packet, it need to get a route to this VTAP host IP, and we can check from the user land use IP route. We can see there's a local cached route to this destination IP goes through this interface, which is this interface, the node interface, and source using this IP. So that's why eventually, if you run TCP down on this interface, and with TCP down port filter on port 8472, I believe. That's the default VXLAN port listener, UDP socket listener port for VXLAN packet. Yes, so it can find the route entry, this entry, and then prepare our socket buffer for the packet and for the VXLAN packet encapsulation, like reserve a header space for the encapsulation. So this is like this is a UDP. Put the UDP header in the encapsulation. This is use the put the IP header in the encapsulation, and yeah, because based on the route, it will use this as source IP header, and this as destination IP header in the VXLAN outer header. Yeah, so this is sending side. When the packet come here, this is the receiving side. So the receiving side is before it receives the packet, there is actually there is a VXLAN socket already created in the kernel space. So this is the actual socket, VXLAN socket creation function, and it's basically create a UDP socket in the kernel with listening port 8472. I believe, if I recall correct, that's the default listening port for VXLAN packet in Linux kernel. And so this is the actual VXLAN packet receive function. Once this function receives the packet, it will pull out the VXLAN header and look for the VXLAN identifier ID, and then enqueue the packet in the receiving queue. So yeah, and so notice on my worker node, I have the same similar entry as on the master node. So if there's a packet coming here, and send it, and with destination MAC address with this guy, it knows to send the remote VTAP host is the master node. So all these things is created automatically by the Flannel daemon running on each node. Yeah, hope I explain this time a little better. Yeah.